Hi guys, today's topic is about process scheduling. So process scheduling is a method by which an OS manages process execution. So the OS the which manages the process. The process can be in different ways. It ensures efficient CPU usage, multitasking and responsiveness. The CPU usage can be maximized. So next, why is process scheduling important? So in OS handles multiple processes at once, efficient process scheduling. In modern days, the people are in need of multitasking where OS need to handle multiple processes at once. So it prevents CPU bottlenecks. It ensures fairness among processes, minimize response time in interactive systems. And next, the objectives of process scheduling. The objectives of scheduling is for maximizing CPU utilization, as we have already seen in the CPU scheduling. So the process scheduling and the CPU scheduling main aim is to maximize the CPU utilizations. It minimize waiting time and response time. It's same like as the CPU scheduling, where it also minimize the waiting time and response time. But in the CPU scheduling, it will minimize the turnaround time, and here it ensures fairness and avoids starvations. Next, type of process scheduling. So there are three types of process scheduling: long-term scheduling, short-term scheduling, and medium-term scheduling. The long-term scheduling refers to determines the which process enter the system. So it will determine which process need to enter the system and which we not need to enter the system. The short-term scheduling. The short-term scheduling selects which process gets CPU time next. So the short-term scheduling will decide which process need to go next after the process executed, which in already in the ready state. Next, medium-term scheduling. The scheduling swaps process in and out of memory. So when the process need to be executed, it will put the process in, and after executing, it will throw out the process out of the memory. First, the long-term scheduling. The long-term scheduling determines which jobs enter the system. So, as I already said, the long-term scheduling refers and determines which process. So it's here I have given is a job. So the process or a job can enter the system and which do not. So 1 minute wait. Here it controls the degree of multi-programming. So eh, there are difference between multi-processing and multi-programming. Here it will control the degree of multi-programming. Example, batch processing in a large-scale system. So its example is batch processing. Next, short-term scheduling. So the short-term scheduling, select the process that gets CPU time next. So it will select which process need to be executed next. It works at the millisecond level. So it's need to work very faster so that the next process can execute even more faster. So example like switching between apps in an OS. So it's like as it's switching between the apps between the OS. So I can switch many apps in the OS in my Windows. So next, medium term scheduling. The medium term scheduling manages memory by swapping processes in and out. As I have said, if the process need to execute it, so it will put in the memory. After being executed, it will throw out of the memory. It reduces system load by temporarily removing processes. Example, virtual memory paging. The virtual refers to the temporary memory. Next, process steps in scheduling. So there are five process states: new, ready, running, waiting, and terminated. So the new refers to the process created. So the new process can be created by the state called new. Next, ready, waiting for CPU execution. So it will wait until the process which already being executed will be finished. Next, running. Process currently executing. Waiting for input and output. Next, terminated. Process completed. Next, process control block PCB. It stores process information like process ID, process state, CPU registers, and memory allocations. Next, schedulers and their roles. The scheduler manages process execution. Long-term scheduler, short-term scheduler, and medium-term scheduler. The long-term scheduler manages process admissions. The short-term scheduler decides which process runs next. The medium-term schedulers handle swapping. It's like long-term scheduling, short-term scheduling, and medium-term scheduling. Next, context switching in process scheduling. So the context switching occurs when a running process is interrupted. When a process is running and if any process interrupted, it will can leads to switching. CPU state is saved and restored for another process. Overhead. Too many quantum switches can slow the system. So if multiple processes are switched when the process is being executed, then it will affect the efficiency of the system and slow down the system. Next, scheduling criteria. The scheduling criteria includes CPU utilization, keeping the CPU busy. So the scheduling will always keep the CPU very busy. Next, throughput. The number of processes completed. Turnaround time. Turnaround time refers to the time process submission to completion. Waiting time. Time spent in the ready state. Response time. Time to wait. Time to first CPU response. Next, preemptive versus non-preemptive scheduling. The preemptive scheduling allows process interruption. Example, round robin and scheduling. Non-preemptive scheduling. Process runs until completion. For example, first come first serve and shortest job next. Next, process scheduling algorithms. So there are many process scheduling algorithms include first come first serve, shortest job next, preemptive scheduling, round robin, multi-level queue, and feedback queue scheduling. So the scheduling algorithms I have already given in the CPU scheduling. You can refer that video. So I will take the CPU scheduling in an outer way. First come first serve. The process which come first will be first served. Next, shortest job next. The process which have the less burst time will be executed first. Next will executed uh, where the burst time is less. Next, priority scheduling. The process will be executed based on the priority which they have given. Round robin. The round robin, according to the time quantum, the process will be executed. Multi-level queue scheduling. The process are divided into queues based on the priorities and the process will be executed. The feedback, the process can be moved in between the queues dynamically. Next, challenges in process scheduling. The challenges involve including strivations. The strivations refers to the process where it communicate between each other and the switching, the rapid switching can will affect the efficiency of the process. The high contrast switching overhead. As I have already said, the rapid switching can decrease the efficiency of the system, which slows the system. The fairness in shared systems and the real-time scheduling constraints. The future trends in process scheduling. The future trends in process scheduling are the AI-driven scheduling, then cloud distributed scheduling, quantum computing process scheduling. Conclusion. So process scheduling is essential for system efficiency. Different algorithms have trade-offs. Future advancements will optimize process execution further. So thank you for watching this.